Corporate finance practice problem using Excel. We're going to find the bond market rate or yield if we know the price. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side. We're going to populate that information into the blue area on the right-hand side. Information including the bonds outstanding have a par value 1,000, the percent 8% matures in 10 years. This information we would assume if we had like a physical bond, we can derive from the actual physical bond. Then what we have that's not on the bond derived from the market is the selling price at the 1,090. So many times we consider this and we think about the idea that we have the market rate and then we try to find the price. Now we have the price and we're trying to think about what the rate would be, what the market rate would be, what the yield would be, what the yield to maturity would be. So as we think about the price, note what we are getting. We're going to be getting the $1,000 if we were to purchase the bond, right? The bond's going to pay $1,000 at the end, in this case 10 years, and it'll pay 8% or $80 on an annual basis. We're assuming this being an annual bond. And then we want to figure out what the rate would be. Now, normally, when we did this in prior problems, we figured it when we knew the rate and we tried to figure the price, and we did that by basically present valuing the annuity portion, present valuing the one payment of the 1,000 to get the total price if we knew the rate. So we could use Excel then to kind of figure that out with our tool, our trusty tool of GoalSeek, or we can use another Excel function that's designed specifically towards this goal. So we'll use both of those methods here. Note you can do this mathematically too, but it's kind of painful to try to do this with equations, with algebra. You can do that. We won't practice that here because we'll probably be wanting to use functions to do it. So we'll basically back into this with Excel. So let's first think about the GoalSeek kind of situation. We're going to say, okay, if I get to this price, I know that if I had the rate, I could calculate the present value of the annuity with the market rate, present value of 1, and then add those together, and that would give me the price, which I know the end result will be 1,090. So what I'm going to do is pretend I have a rate over here, and then calculate this using the pretend rate. And then I'm going to use GoalSeek to use trial and error to find the rate that would be used in order to get the end result to be where we need it to be, that 1,090. So let's first do that, and then we'll do the second equation, like a function that's used in Excel specifically for this task, and we'll do both these methods. Really useful to get a concept or an idea of how to use this GoalSeek, because if you do know a function or how something works one way, GoalSeek can kind of allow you to use functions in a similar way as you might use an algebraic type of equation. Instead of reworking the algebra, however, you just basically force solve for the unknown using trial and error, which is not difficult to do if you have a computer. So let's first pretend what the rate is going to be. I'm just going to make up a rate, 5%. 5% is going to be the rate. I'm going to calculate this and come to the payment based on that 5%, which will not match this 1,090 unless that happens to be the answer. And then we'll use Excel to say, hey, change that cell to make this end result be what we know it should be, the 1,090. So let's do our formulas. The annuity calculation would be the negative present value shift 9. The rate, I'm going to assume the rate, this is our unknown here, comma. The number of periods, that's a known, that's 10, comma. The payment then of our annuity would be the 1,000 times the 8% or $80. And then enter. So that would be the annuity given this 5% rate. Not correct, but that's the first component. The second component will also depend on this cell, us present valuing the 1,000 back to 10 periods to the current period. So that would be negative present value shift 9, or the rate would then be this market rate, which we have to assume is that 5%. And then I'm going to say comma. Then we pick up the number of periods, which is 10. Comma, comma, because now I'm present valuing 1 and not an annuity, and I'm going to pick up the 1,000 that we want to bring all the way back to the 10 years to the beginning. There is that. Now, if we add those two up, that would be the price that we would assume, present value of the annuity, present value of 1. So there's the 1,232. That's too high. It should be 1,090. So now we want to say, I could change this rate, like I could say, what if it was 6% and so on and so forth? What if it was 8% and whatnot? and try to basically get this to where it matches, or we could use Excel to force that kind of calculation to do. Excel can do that quite quickly. How? We go to the data tab up top. We go to the forecast section, and then we go to the what if, and then goal seeking goals. What is the goal? Excel then asks, like, what is your goal that we seek? And we're going to say that we want to change this cell, and we want that cell to be this cell, which I have to hard code in there if I want to seek the goal. We want that to be 1090. We want to do that by changing the rate in this yellow cell. So we want to change that to what it needs to be in order to make the result what we know it should be, that 1090. That is the goal that we seek. So we're going to say OK, and Excel's like, there it is. That's the answer, the 6.76. So that's one way you can come up with the rate. The other way we could do that is we can use a function designed specifically to do that. It would be a rate function. You got to be a little bit careful here because you have to make sure you're using negative numbers where it wants to see negative numbers on things like payments. So it's a little tricky. Let's do this a couple different ways. I'll do it with like the formula box, and then we'll do it with just like the normal formula, and then we'll double check it. So one way to do it, if you don't know and you want more descriptions on a function, you can go to the formula tab and use the insert function up top, and then I'm going to type in rate. We want to use the rate function. There it is. And this gives you like a dialog box, which sometimes gives you some more information about it. So we know the NPER is the total number of periods for the loan or investment. That's straightforward. That's 10. We know that. The payment, the PMT, is the payment made each period and cannot change over the life. So there is a payment. This is the annuity kind of component. That's going to be the 1,000 times the 8% or $80. And then the present value, that's going to be the present value, the total amount that the series of future payments is worth. And here we're saying it's that 1,090, which is a little tricky because that's not really the present value of the annuity, but the present value of the annuity and this present value of 1. But we're going to take care of that present value of 1 with this component, the future value. That's going to be this $1,000. So that's taking care of the two components here. So we've got the number of payments, we've got the annuity being taken care of here, and that future value of 1. Now the thing that's a little bit tricky is I don't believe it's going to give me a result. You could see no result down here unless I make the present value or the payment. I think the payment needs to be a negative number. It wants to see a negative number there. And then the future value, I think it wants to see a negative number. And then it will then give us our result, which is going to be that 6.73. So without those negatives, it doesn't pick up the proper formula. So be careful about that. Then I'm going to say OK. And there's that 6.73 again. Let's do it without the dialog box this time because we don't want to depend. We don't need the dialog box. We can just say equals the rate shift 9. The number of periods is going to be 10, comma, payment is going to be then the 1,000 times the 8%, but that needs to be negative. So I'm going to put a negative before the before. Otherwise the function like gets upset and spits out some kind of stupid thing instead of the answer. And then the present value is going to be this, which is going to be the price. That's the present value, comma, and then the future value also needs to be negative of that 1,000. So there we have it again. Let's go ahead and say OK. And so there we got it again. And if we prove it now, we prove it with basically our annuity function. We'll just do the same thing we did up here. And now we know that if we had the market rate and I was then to calculate the price the way we've done it before, then as easily as possible with our annuity kind of function, this is what I think is as easy as possible. We're going to say this is going to be negative present value shift 9. Rate now is that rate, comma, number of periods, 10, comma, payment, 1,000 times the 8%, and enter. And then the present value of that 1,000 will bring back to the current period, negative PV, shift 9. Rate is going to be that, market rate, comma, number of periods, 10, comma, comma, and then the future value, 1,000, and enter. And if we add those two up, then we should get to our price. Adding these two up, getting to the price, the 1090. double checking, verifying that this is indeed the rate that we were looking for.